Okay, so let's look at example 4. In this example, we're still revolving around the x-axis, so our cross sections will still be circular. But this is called the washer method, and you'll see this is just because, washers have holes in them. And you'll see that when we revolve this region around the x-axis, our circle is going to have a hole in it. Okay, so let's think about what this means. So we're revolving the region bounded by y equals 2x and y equals x squared around the x-axis. And so that's this region here. And so when we revolve this around, this red line is going to, land on this red line, and there's going to be a purple thing over here. And then our cross section, though, is going to be some circle with a hole in it, right? So, and the way we're going to compute this area, so think about the area here. So the area of a circle, general is pi r squared, but it's the area of a washer. If we're missing a circle from the middle is going to be, so let's see here. So we'll call this one little radius, and then if we go all the way out from the middle, call it capital R. So the area of this thing is going to be the area of the outer circle, so pi large R squared minus the area of the little circle, pi little r squared, so it's area. And this is outer circle minus inner circle. Okay, so all we need here then to finish this problem is to know what the area, what the radius of these two circles are. And so we have the y-axis going through the x-axis going through the middle. And so first, let's think about what the area of this is. So we're going from the middle, and the first thing we hit is the purple function, which is y equals x squared. So this smaller radius on the interval that we're looking at is given by x squared. And then if we go all the way out from the middle all the way out, we're hitting at the top, we're hitting the function 2x. So for each x value, we have the outer circle is radius 2x and the inner circle is x squared. And so the area function for us in this example is going to be pi outer circle 2x squared, and then we have to subtract off the inner circle, which is x squared pi x squared. And maybe we'll clean this up a little bit before we go over. So this is going to be pi times 4x squared minus pi x to the fourth. Okay, and in general, we're still doing the volume is equal to AB area function dx. And so here's my area function. And so let's go over here and take computing the volume. Volume is equal to pi 4x squared minus pi x to the fourth dx. I can see this starts at 0 probably, but the question is, where am I ending? And to do that, we can just set the two functions equal to each other. So if we assume the y values are the same, then and then see what the x values need to be. So I can just subtract this over. I have a common denominator of x. And so x equals 0, like we suspected. So this is 0, and then this is x equals 2. And so it ends over here at 2. And so those are our bounds. And I left the pi's out front on these on purpose so I can bring them all the way out front. And now I'm just dealing with 4x squared minus x to the fourth. And these are polynomials, and I know how to take those antiderivatives. So I have pi 4 times 1/3 x cubed minus 1/5 x to the 5th from 0 to 2. So this is really pi 4/3 x cubed minus 1/5 x to the 5th from 0 to 2. So plug that in. So I get pi 4/3 2 cubed minus 1/5 2 to the 5th. And then plugging in 0. Here, and then I'm going to run our room, so I'm going to put the answer over here. This is equal to, well, in the end, this is right over again. In the end, we get 64 pi over 15. All right. So all this is 0, and then this is 32 over 3 minus 32 over 5.